Welcome to the course on rapid manufacturing. We were discussing the lecture series on product development process, and based upon the feedback which I have got from students, I have noted down some modifications, which as and when I walk through in these presentations, I will try to add those comments, suggestions, whatever they have given. So, we have been discussing on product and its characteristics, evolution of product development, sequential product development, stages in generic product development process, and now we are more focused towards design specification in the process. So, last lecture we were seeing how do we take customer needs, then convert it into engineering specification, and then what we do is we try to develop conceptual scale details, and then we go for engineering details, then we will release it for production, and then we go for marketing. So, this is a sequence it follows, right. So, now we will start focusing more on design specification. So, it is nothing but establishing the design specification is one of the most important and difficult. Please understand these two terminologies, you have to keep it in mind. It is an important as well as a difficult element in the overall design process. The design specification both drive and control the design throughout the process. It drives and controls the design throughout the process. If the specification what is given is over ambitious, or if the specification given is loosely given, so then the product development will be a big challenge, or the developed product will not see success. So, the design specifications both drive and control the design throughout the process. They are especially important during the early phase of the design efforts, because as and when you move towards the later stage of product life cycle, money investment is going to be huge, time investment is going to be huge. So, it is better we take a call, do the corrections, modify our design specifications at the early stage. It is especially important during the early phases of the design effort, because they serve as a principal guideline for the project team at this point in the process. The specifications are so critical to the ultimate design capability and its cost that they must be established early in the process. The design specifications need to be specific to a system and component level as also. So, what are they trying to say is it has to be broad, it has to be focused to certain points. So, it has to be liberal. So, it has to be liberal, it has to be up to the micromanagement also it has to do. So, it is a mixture, you should have everything put in the design specification. So, you can have a design specification running for 30-40 parameters. They have to be established using a sound judgment with wide and in-depth, look at it, wide and in-depth coordination among key participants in the process, and with test and analysis support when appropriate. So, this is very important, with wide and in-depth coordination. Although specifications are established to be permanent and inviolated, they should nevertheless be continually reviewed and revalidated during the design process. So, once the specification is fixed, that does not mean that is the ultimate. You should have a scope for improvement. So, that is what it says, to nevertheless be continually reviewed and revalidated during the design process, at least until the design is frozen, to ensure that they continue to reflect the goals and the objectives of the project. So, they should continue, the iteration should continue reflect the goals and the objective of the projects. To establish the design specification, it is necessary to prepare a list of matrices that reflect the degree to which the product meets the predefined needs. The competitive benchmarking can be used to determine the relationship of the new product to the competitive product. So, whenever you try to develop, that is why I always used to say do the state of art. So, state of the art search, that is nothing but state of the art search. That means to say what is available nationally, what is available internationally. You should look at a similar product or almost the same product and then try to redefine your specification such that you can meet out to the same customers in a better fashion. So, state of the art search is very, very important. So, the state of the art search tells very clearly what are the competitive parts or products available, and then what you can do is you can do a benchmarking of it and try to come up with your product. Once the target values are assigned to the selected metrics and specifications are refined, the next stage conceptual design can be started. So, this is a block diagram which talks about design specification. Prepare a list of metrics and then you do a benchmarking and then you try to do a value assignment to metrics. So, here you will have benchmarking should be done internally, it should be done competitive and it should be done in generic. So, your benchmarking should be done in all the three levels: internal level, within the company, competitive level and in the generic level. Prepare a list of metrics. Customer needs specified in the previous steps are translated into measurable characteristics that will reflect the degree to which the product satisfies the need. So, it is in a crude fashion understanding customer need and converting into engineering requirements. So, that is what is measurable characteristics are that. The major assumption here is that the translation from customer need to metrics is possible and each need can be represented by one matrix, thus meeting the matrix will lead to a customer satisfaction. Theoretically, this assumption is valid, but there are needs that cannot be measured or that are difficult to be represented by a single matrix. So, it is very difficult to have a single matrix. So, what we will do is we will try to have a combination of matrix and then try to prioritize and then try to make your prepare the matrix for the specification. So, in this case engineers can make the assumption that satisfies more than one matrix will eventually lead to satisfying a certain need up to an acceptable degree. A useful tool that can be used when preparing the matrix list is the needs matrix matrix, in which the row of the matrix will correspond to the customer need and the column corresponds to the matrix. A generic need matrix is illustrated in the next slide. So, we can understand more. When a mark in a cell in the matrix indicate that the need and the matrix associated with the cell are related. So, this is how is the need matrix graph look like. Here are the needs, here are the metrics. Okay. So, the needs matrix will represent the relationship between the needs and the metrics and ensures that all the customer needs are considered in this matrix. So, moment you start putting on a piece of paper and start assigning it in a table form. So, you can give more data, you can try to cluster data, you can do more amount of logical interpretation of the data which is available in front of you. So, here the data which is available is need and metric matrix we are trying to develop. Next is benchmarking. Benchmarking is defined as the continual search for the implementation of practices that could provide a competitive edge. That is what is benchmarking. So, we always do benchmarking, and today when you ask a psychologist, they say please do benchmarking with yourself, that last time you performed this, now you should perform much better. That is what they try to do. All the sportsmen are clearly given an instruction that they should benchmark first among for themselves. For example, you are running a athletics 400 meters, first you clock your time. So, it was, for example, it was 20 seconds today, next day if you can do it at 19, 18. So, those are benchmarking improvements which you can see. So, benchmarking, when you talk about sports and individual personality, they say do for yourself, but when you talk about a product, it will always be with the other competitive products in the market, okay, so that you get an edge. Companies differ in the way they implement benchmarking, but it is the usual adopted as a corporate strategy used to identify the industrial leaders, promote proven techniques and approaches, establish meaningful goals, perform business forecasting and analyze the overall internal process. So, corporate strategy is to identify the industrial leaders. For example, you are making a T-shirt. So, in a T-shirt you have buttons. You try to look at the buttons which are available from a successful or from a very successful product or very proven product. You take those buttons and then start looking at what are the problems faced in those buttons, and if you are developing, how is your product superior or inferior to that one. So, that is what is, you always try to compare it with the industrial leaders, promote proven techniques, approaches, establish meaningful goals. You should not copy and repeat the same. When you do benchmarking, you always surpass the standards whichever is available. So, you will try to go more than the products which is available, perform business forecasting and analyze the overall internal process. Benchmarking can be categorized into three major categories: internal benchmarking, competitive benchmarking and generic benchmarking. When we talk about internal benchmarking, in this type of benchmarking, similar activities in various locations, departments and units are evaluated to gain data accessibility, that is internal benchmarking. Competitive benchmarking, this type of benchmarking is concerned with identification and evaluation of direct competitors to obtain data relevant to the product under the investigation and to find comparable processes to gain competitive edges. This type of benchmarking is concerned with the identification and evaluation of direct competitor. I make a shirt, you make a shirt, I see how better is my shirt than you. So, identification, concern with the identification and evaluation of direct competitor to obtain the data relevant to the product under investigation. So, my shirt, your shirt, and to find comparable processes to gain a competitive edge. My shirt, your shirt, how is my shirt better than your shirt in terms of whatever 1, 2, 3, 4, 5. So, that is what is comparable process. Generic benchmarking, the objective here is to evaluate the organization and their function that are considered to be the industrial standard to achieve procedure standardization. So, generic benchmarking is generally done for industry level. For example, rather than looking at one product, you look at the complete process of the company, complete process of whatever happens. So, the objective here is to evaluate the organization and their function. For example, I am running an education institution, you are running an education institution. How is your institute better than mine? So, what are all the good practices you do, and I try to customize the good practices whatever you do there to my requirements. Okay. So, that is what it is. The objective here is to evaluate the organization and their functions that are corresponding to be the industrial standards to achieve procedure standardization. The last one in the process is value assignment to metrics. In this step, the design team synthesizes all the information acquired to set actual values for the metrics. Two values are usually assigned to each metrics. One is the ideal value, which can be defined as an optimum value. that the design team hopes to accomplish, and the other is the minimum acceptable value, which can be considered as the lower limit that can satisfy the need. So, are you able to understand this? I will put you an example. I have a examination wherein which I have to get marks. That is a competitive exam, I am writing it. So, if I wanted to qualify the examination, I should get 60% marks. If I wanted to get a good rank admission in a good school, I have to get 90% marks. So, that is the difference here. One is the ideal value, which can be defined as the optimum value that the design team hopes to accomplish, 90. 90 here is higher, but that is what is optimum if I want to get a good admission in a good college. And the other one is minimum acceptable value, which can be considered at the lower, 60 marks in the examination. So, if I get 60, I will get an admission. If I get 90, I will get a good college admission. That is what is given here, value assigned to matrix. Usually, design will progress to achieve a matrix value between the ideal and the lower limit. So, you will, this is the top level, this is the bottom level. So, you will always try to have somewhere around here. This is what designers look out. This is optimum, this is minimum. Designer will always try to designer's value. In all cases, the design team should have the ideal value as their primary objective. After the problem has been clarified and completely described, the viable solutions are identified and optimum approaches are selected. The problem solutions or concepts are defined as an approximate description of the product or technology that meets the stated needs. The conceptual design stage is concerned mainly with the generation of solutions and concepts. So, these are multiple solutions, for example, from moving from x location to y location. I have to go to x to y. So, I can go like this, I can go like this, I can go like this, this and I can go to y. So, there are multiple solutions generated, some are feasible, some are infeasible, but you start generating conceptual ideas, okay, and later you can kill some ideas which do not even come in the optimum viability zone. Okay. So, the conceptual design stage is concerned mainly with the generation of solution, let it be viable, not viable, we are least bothered, that satisfies the need, and it selects a concept that is most suitable for matching the predefined design specification. The major steps that can be identified in conceptual design phases are the concept generation or generation of idea begins with a defined problem statement, which you have already done, that includes customer market need, design specification and ends with several product concepts for which the design team will select the most suitable ones. The systematic procedure is given in the in this slide. So, here you will have problem, formulation, then you will have overall function analysis,